Several years ago, I put together this self-contained terrarium ecosystem. I had always found it fascinating how the complex processes of Earth's biosphere could continue functioning on such a miniature scale. Over the years, the jar recycled its nutrients and sustained organisms from all 6 kingdoms of life. However, due to temperature fluctuations, small amounts of water vapor would gradually escape through the lid gasket, and 4 years after it was sealed, the system had lost enough moisture for the majority of its inhabitants to perish. So today, I've decided to head out into the woods to collect fresh biomass in order to create yet another microworld, only this time it will be guided by science. First, let's run through the basics of what we need for a habitable planet, or more precisely, a habitable terrarium. Just like any natural ecosystem, we're going to have to create a gradual transition between the deeper inorganic layers and the biological upper layers. Such a setup is crucial as it prevents the rotting of biomass and the formation of anoxic conditions, capable of producing toxic gases such as ammonia and hydrogen sulfide. Now, building on the idea that all life depends on water, we must ensure that the water cycle can sustain itself, primarily through evapotranspiration, the process by which plants release water from their leaves after using it to transport nutrients from the soil. The moisture then condenses on the glass, where it becomes available to other organisms. Eventually, it filters back through the deeper layers and returns to the aquifer, allowing the cycle to begin once again. Alright, enough theory, let's get to the actual terrarium. Here I have prepared all of the necessary materials. First of all, we have our container, which in my case is a 2-liter jar. Next to it is a spray bottle filled with a solution containing a small amount of potassium nitrate and a few drops of Gillard's F2 formula, a nutrient mix containing trace metals, phosphates, nitrates, and vitamins commonly used to support the growth of algae, plants, and microorganisms. The reason why I'm using a spray bottle is because it is very easy to overshoot the necessary amount of water for such a small system, which is why it's best to hydrate everything with a gentle mist for better control. Next up, I have my sand and limestone pea gravel, which will serve as the aquifer. To the right of it is some potting mix with a bit of composted cow manure, as well as a handful of soil collected from a grass meadow in order to introduce seeds, roots, and microorganisms that can increase the biodiversity. In the last jar, I have some cocoa coir, which will serve as a long-term carbon source and as a physical separator between the soil and the pea gravel. Finally, we have some activated carbon, which will help filter water as it passes from the soil into the sand. And at last, but likely most important, I have several mosses and a horsetail plant, all of which I collected near a creek. I begin by placing roughly 2 centimeters of sand at the bottom of the jar. Above that, I add most of the gravel and gradually alternate between the 2 layers to create a transition zone resembling the natural deposition of sediment over time. Next, I add a thin layer of cocoa coir, whose fibrous structure helps maintain separation between the sand and soil layers, so each can perform its function more effectively. Afterwards, I wash the coir dust from the glass using some of the nutrient solution. Above that goes a thin layer of activated carbon, which will help purify the circulating water and improve long-term stability within the ecosystem. The jar is now ready for plants, and the first to go is the horsetail, since it has the largest root system contained within this clump of clay. I will need to gently flatten it to create space for the remaining plants and stones. This is a piece of sandstone with some moss growing on it. I found it in a shallow creek, and I believe it should adapt well to the terrarium since the humidity inside the jar is expected to remain constantly high. I then added a small amount of wild soil, which appeared to contain seeds along with dormant plant material, waiting for the right conditions to grow. After adding the final amount of fertile soil and gently rinsing everything down with the nutrient solution, I began arranging and planting the mosses throughout the terrarium. Meanwhile, I managed to capture a pillbug on camera, although later I had to remove it from the jar since isopods generally don't survive well under such confined conditions. For those of you trying to relate this to my previous content, I would like to emphasize that life in a jar is simply another form of chemistry. However, unlike a straightforward reaction in a flask, this vessel contains millions of intricate reactions containing, balancing, and interacting with one another. And yet, when observed closely, such a miniature ecosystem can become profoundly fascinating to watch. After the final cleanup, the ecosystem needed time to self-stabilize and recover from all of the shock that its organisms experienced during all of the agitation. I also marked the lid with the assembly date so I could keep track of exactly when this miniature world first began. I placed the jar near a window and constantly monitored it, ensuring that it was neither too dry nor developing the smell of decay. Eventually, I began closing the lid and keeping the system sealed for increasingly longer periods of time. After a month, the terrarium did not appear to change very much. However, for such a fragile system to remain stable for this long already represents a significant success. So now, let's take a closer look at the microscopic changes and examine how this miniature world has evolved so far. The first thing to note is the increased faunal activity, along with new plant growth, both of which indicate that the environment is capable of sustaining photosynthesis. Roots from the horsetail have now reached all the way to the bottom of the jar, while new moss sprouts are appearing throughout the terrarium alongside algal growth emerging along the glass. We also now have a tall grass plant, which most likely germinated from the wild soil and serves as another valuable addition to this biosphere. Most of the horsetails continued growing, although one of them was damaged during planting and now serves as a food source for fungi belonging to the genus Rhizopus, a group of fast-growing decomposers that break down dead organic matter and help recycle nutrients back into the ecosystem. I hope that this terrarium will remain self-sustaining for years, perhaps even decades, but to make sure that the system does not lose moisture, I've decided to seal the lid using an all-purpose silicone capable of resisting both water and changing temperatures. In this case, it is important to apply the silicone only to the outside of the lid, so that the inner gasket can prevent any off-gas and fumes from entering the terrarium and harming the organisms inside. For now, the terrarium will remain beneath my grow light alongside several other plants. In any case, I hope you enjoyed the video, and I'll see you next time.